Good afternoon, everyone. I'm Akano Hammed from Nigeria. I'm a biodiversity informatics, in which I involve with geo-information and Earth observation tools for environmental modeling and conservation. And I use geospatial tools such as drones, drone mapping. I use different GIS software, including the free one and the commercial one, which is QGIS, and I use the free one, in which we are going to be using majorly for this program, QGIS. And also, I use Geospatial cloud computing for my remote sensing work, which is basically Google Earth Engine. However, I'm involved with other remote sensing tools as well. And with these tools, I've been able to work with, I've been able to involve in two different international sponsored projects, one from the European Union, in which we use drone technology to map out where a particular species is in abundance in Ekiti State, Nigeria. And also, the second international project I'm involved with is the one with UNDP, and also I've been involved with different local and regional projects as well, and also some freelance work from other continents. First of all, I'm going to thank Geospatial Africa for giving me the privilege to showcase some of my skills in which I've been used over the years, and then that's helped me a lot in this domain, conservation and ecology domain, which I'm urged to showcase it to other students as well, so that they can learn from it and then or try to leverage on it or add to it from what they know before, so that they will use it in their own way, or on the other hand, maybe add this to their own skill set as well. And also for them to be able to use it to answer those questions that we are thinking that they are so difficult for ecologists to answer. So with this, today I'm presenting the talk topic, mainstreaming geospatial technologies to biodiversity conservation, a prospect for African conservation students. Today, this topic is going to showcase to different level of students, whether you're a beginner, intermediate, or advanced student in this domain. Whether you just want to start learning anything about geospatial tools, whether GIS or drone mapping or remote sensing work, for you to be able to apply it to your project work or any contract you've gotten or you are proposed to use it for. So for today, I want to show us the workflow for today's talk, so that we are also going to be move on as speaking as well. So these are the workflow for what we want to discuss today. So I will like to showcase to us, give us an overview of why we need to mainstream geospatial technologies into biodiversity conservation. So research work or project work. And after that, I'm going to give us some key terms in which each and every one of us here, or some of us here, we are acquainted with before. So I'm going to just try to pinpoint some key terms so that we are going to be more aware, or we are going to be, I will be able to remind us about those key terms. So afterwards, I'm going to showcase or try to enlighten us more on some utility function of geospatial technologies. Then I will move to some softwares, tools, and dependency of geospatial technologies in which we can use to answer or give solutions to ecological problems. Then I'll be selective to pick just geospatial utilities for African conservation students. Then I'm going to showcase what products or what tools, when we are using drone as a tool for geospatial technologies, geospatial technologies. So what are the things that we are going to get from the drone that we can use to implement it into biodiversity conservation? Here I'm going to give us few examples of the tools or what we can get from the drones as a geospatial technology tools to biodiversity conservation. Then I'm going to move on to GIS and remote sensing as well, in which we are well acquainted with, and most of us here want to hear about how we can use GIS and remote sensing as well. So I'm going to give us some examples and take us through the workflow, how we can use these tools to give answers to conservation to ecological problem. Then I will also try to be selective to pick out some tools, so important tools in which from our last course, Leon has showcased us to the steps that we are going to take in the course so that you can learn more. And I try to pinpoint some important utilities of GIS so that these are the tools that you might, when you are using GIS, you think they are not, you might think that they are not necessarily important or they are too simple. But these are the basic, these are the fundamental things that you should be acquainted with every time. So in order for you to implement, to solve problems on your own, and also in order for you to get to know or improve yourself with these fundamentals utilities. Then afterwards, I'm going to give us, to showcase us a particular workflow in which we are going to be implementing in mainstreaming all these geospatial tools in the biodiversity conservation. Then afterwards, we learn how can we implement what we have learned, or the skills that you have, how can you use it as an ecology or researcher or conservationist, how can you start implementing it? So because some people don't have skills already, they know about GIS, they know about remote sensing, they know about drone mapping, but the next thing is to use those skills, to implement those skills in real world, so that they will say, okay, what I've learned or what the skill I have, I'll be able to implement it over time. So I'm going to show what some basic strategies that you can use to implement all these skills. Then the resources, few resources that I think is going to help us, or it can help most of us that we are here to go further or start with. And then the last one I'm going to give you, thank you. So I'm moving on to the overview section. The use of geospatial information integration and methodologies for ecologists, researchers, conservationists to solve ecology problem has become a great challenge. If you notice over time, there has been trending in the way we use technological tools. And then in the past, ecologists used to use traditional cartographical methods. And then these techniques is like hard. So it's no more efficient. So there is need for them to be improving on how they use different techniques to solve different problems. For example, let me give you a scenario. For example, let's say a particular protected area or a particular protected area manager was asked to give them a 5 years result, or to estimate for them the impact of fire, the estimated area where fires has been impacted in that protected area, and the influence or the interaction of that fire occurrence with biotic interactions. So this is a question that is very complex for the protected areas manager to give answers to. Yeah, whereas using geospatial technologies, it will be very easier for the protected area managers to implement instead of using a long, wide survey or field survey work, and then which in the long run it might not be much accurate. So with these geospatial technology tools, the protected area manager can easily estimate the area in which are impacted with wildfire, then also do some modeling and know the interactions of this threat to biotic interaction in the protected areas ecosystem. So with this call for multidisciplinary tools and interaction and practical approaches for different ecological and conservation studies, so that they can bring different tools for them to make their work easier in order to provide a solution based or a problem-solving approach to conservation issue. For example, in the drone mapping domain, there's a problem in which it's very difficult for ecologists when they try to use their drone to get a reasonable result, the drone images or video in order to match to get a reliable result. So by over time, ecologists have been able to gather together with different multidisciplinary professionals to create a free tools in which they can be used for their drone mapping. like web majorly is they just invented the tools not quite long, WebODM. So and this is one of the geospatial tools. So these problems are scored for this multidisciplinary approach in which ecologists have been using over time. So the use of these tools allow researchers to collaborate easily in the problem-solving techniques. So it will help them enhance their problem-solving techniques over the time. So hence, its dependencies are now great exploration for researchers to use or to integrate into their various studies. Then to the key terms. Some of the key terms I want to show to us. Geospatial. So most of the time when we hear about geospatial, it sounds abstract to some people. But for it to be sounding abstract, we can make it so that we want to show it to us so that it's not be abstract. Geospatial, what is geospatial? Because when you understand the fundamental basis of particular terms, it will be very easier for us to use it or to gather it up to other resources so that we implement them in real life. So geospatial is a term that is used to indicate given information or data tag of geographical components on Earth, which could be geographic coordinates, a zip code, or an address, or etc. So I'm going to use this figure to explain to us what I'm really saying. We see that we have different features here. So each feature, the first one at the top represents different street lines in form of lines, that is street. Those things that we are looking at is not just another features where we are in the geospatial domain. They represent a basic information in which majorly they are in form of coordinates. They have numbers. Whether we want to take into vector format, that is, it may be in XY coordinates, but if it is in raster, it will be in theta number, which we are going to have in our pixels. So these different features that we are seeing before, we have the last one here, which combine everything together. So they have different information in them. So that's basically what we mean by geospatial. Geo, that means a phenomenon that has a spatial, a coordinate information in it. Then we move on to geospatial technology. So the geospatial technology is not just a word that just comes like that. So it's an integration of two words. We have geospatial, in which we already understand what geospatial means, then technology. So these two words in the emerging technological field in geography. The studies geographic information system, that's GIS, remote sensing, global position system, the GPS, and the drones. Also, these drones can also be called, or is being called by other expertise as remote pilot aircraft system, and some call it unmanned area vehicle, which is UAV. Most of the time you see UAV, it's basically drone. And some call it unmanned area system. So these tools in which all these four tools, they serve as functional tools as a reference Earth data acquisition. What I mean by this is that most of these tools, we use them to acquire reference data on Earth in order for us to get our features, our phenomena, our geographic phenomena on Earth as a particular information. Like the streets that I showed the other time, the tree, all those things, they have information in them. So these tools gave us a reference one, a reliable one. Okay, this is a particular feature with a reference information. And also these tools can be used for spatial analytics, modeling, visualization, and simulation. And we're going to see some of these examples when we move on. Then move to GIS. So, and most people are used to GIS, and we accept it like that. So, but in real times, when we heard about the times, we know about what is the fundamental understanding of these tools. So, a GIS is a system for capturing, storing, analyzing, visualizing, modeling, and simulating Earth reference data. How can we use GIS for data capture? There are some different packages in QGIS in which you can use to extract data. You can use it to extract data, and even in ArcGIS as well. Yes, and also you can integrate different layers. We have WMS, the open streets, and then just georeference your data, digitize them, and then you have your vector in which you can rationalize it in form of raster data. So that's how you can use a GIS to capture your data. I'm just giving an overview. And also we can store our geospatial information whereby we create a geodatabase. So this storing techniques or geodatabase monitoring is quite acquainted with most people that are in real estate. So they use it a lot in keeping their database. They use GIS as a very important tool to manage a big database. And also we can use GIS for analyzing. So we can use for different analytics. We want, okay, for example, let's say we want to know where we have more abundant species, or want to know which area is being threatened, in which we are going to use different spatial analytical methods and modeling techniques. And we're going to try to visualize. We really want to see, because there are some data that there's the basic difference between the data analytics and the geospatial analytics is a visualization techniques. So what a data analysis does, a GIS expert can move on to show it in form of a real life or a real time approach using maps. And then we can go further to do modeling. We have an particular information right now. We can use that information to know in the next 2 years, 10 years, 5 years, 50 years, what can happen with our ecosystem, or a particular species abundance, or how threatened is this particular area is going to be, how severe the threat that is may occur in this particular area is going to be severe in the next 5 to 10 years. We can model that with our GIS tools. And also we can do some simulation about our reference data. So that's the basic things that this GIS is encompassed with. So it's also a system for capturing, storing, analyzing, visualizing, modeling, and simulating Earth reference data. And also, we move on to remote sensing. So basically, the fundamental thing we should understand, these times might not be the real times that, because we have different times over there, but trying to break this down in a way we can understand it fundamentally. So remote sensing is the acquisition of information, Earth's phenomena, using reflected and emitted radiation from remote distance objects, such as drone or aircraft. That aircraft can be in terms of drones or helicopters. So they use helicopters or drone as well, so as to get remote sensing data. So if you see this, the figure behind the text, it shows a satellite in which that satellite is reflecting and emitting radiation from the Earth's objects, from geographic phenomena on Earth's surface. So all these objects on Earth they reflect different, they have different dramatic rays that they are reflected back. So these satellites or our drone that will mount different sensor or camera on it, what they are reflecting, they are going to be capturing it as a geospatial information in which they are preprocessed, like the satellite imagery. So when it is being captured, it's going to be processed before you have access to it. And your drone as well, you have to be processed before you have your data. So that's what's more sensitive basically. And we have single band and the multi-band images, in which when you capture your data, so your data is going to be in bands, different bands. It can be in one single band or in multi-band. So what I mean by single band is have just one component in it, but single band, multi-band can have different band with different radiation, visible light, NIR, and all the likes. So the next term we want to showcase to ourselves is GPS. So GPS is basically a radio navigation satellite-based system that uses, transmits, and receives signals and algorithm to synchronize locations. So when you hold your GPS is connecting with a particular satellite. So because if you want to use GPS, it's recommended that it has at least 9 to 12 satellites, and you can see it on your GPS that, okay, GPS you are using has been connected to 9 to 12 satellites so that you get a real information, you use to share information from different phenomena that you want to get your data from. So that's what basically GPS is used to capture different data. You can use to have your location-based data. So that's what's the functionality of using GPS. Then the drones. Drone is information retrieving devices that do require semi-human intervention to pilot, process, capture spatial data with a camera or sensor being attached or mounted to it. So as I said earlier on that it's being called remote pilot aircraft system, UAV or UAS. So the terms I put there as semi-human intervention is we have different techniques in which we pilot drones right now. So there are automatic way and then there are manual ways, but the most one that is very common is the semi-human intervention to pilot your drone, whereby you start the drone and the drone, or you just ask, you operate the drone in which the drone moves on its own and give you your information, and then you do other things with your data. And then let's move from the geospatial domain to conservation domain a bit so that we can integrate the two together. So then we go to how we can mainstream these two domains together, because it's different domain, geospatial domain and the conservation domain, they are in two different things. So we have showcased some geospatial terms, then let's go with some biodiversity or conservation terms as well. The first one here that we are going to discuss is biodiversity. So we all know what biodiversity is, but this one is just to remind us what it means, or it's just going to simplify it for us. So biodiversity can be simply put as a variation on life, the variation of life on Earth. That is, varieties of different life forms on Earth that covers different areas of the biosphere. So biosphere is the region on Earth in which life exists. So the region on Earth which life exists, and we have different variations of these different life forms, is what we mean by biodiversity. And this biodiversity, we have different types of biodiversity. We have the genetic diversity, we have the species diversity, and we have the ecosystem diversity. So for the genetic diversity is the variation of genetic information, that is traits, inherent traits, or the one that is not inherited within living organism, which it can be morphological or physiological traits. So it's a variation of genetic information, the traits within living organism on Earth. It includes the animal, plants, and microorganisms. For us to understand these terms very well, we're starting with African rhino. So we have basically two rhino in Africa. We have the white rhino and we have the black rhino. So the different morphological genetic trait that we can point out from rhino is with their snout on their horns. So it is their existing traits between these two morphological features of these two rhino, the black rhino and the white rhino. So they are the way the snout, how you see it morphologically, and the horn. So this morphological trait is different from each other, and this is a variation between one species. So that's basically what we are talking about genetic diversity. And then species diversity is a variety of organisms on Earth, which include the abundance, richness, and taxonomy diversity. In this, we are going to see that we have zebra and we have antelope. So in which, when amongst our fauna and flora species that we have on Earth, there are different forms as well. We have zebra, we have lion, we have elephant. So the variation between all these fauna and flora species that we have is all human species diversity. And then the last one is the ecosystem diversity. So it is the variety of species that is specific to their geographic extent or location. Basically in Africa, we have different ecosystems. So from the rainforest to the desert. So that's the variation that we have as you're moving on, or you're moving in different regions in Africa. You are moving from the rainforest to savanna to desert. This is basically when you're experiencing different ecosystem diversity. And then the next thing is conservation. So conservation can be expressed as judicious or wise use of resources. How we use a particular resources very well, in which how we use it sustainably, not that we are preserving it alone, we are also using it and then we are sustaining it. And biodiversity conservation is a way of protecting the variety of genetic species, habitats, ecosystem diversity, in which humans depend for survival, such as food, air quality, health, food, shelter, and all sorts of things that you can think of that we can derive from the ecosystem that we are in. Then that's all we have in terms of being able to gather for us, so that we are going to understand these two different domains. One, we have the utility function of geospatial technologies that I want to expose us to here is one, the drone and the GPS. I class them as one, the remote sensing and the GIS. So the drone is for data. We can the utility function we can get from the drone is acquiring data. However, we can move on to use it in processing our data as well and doing some manipulation with it. But basically, we do have to use drones to acquire data, whether images or videos for different things. Maybe we want to monitor habitats, a particular habitat component, we can use drone to capture our data. And let's say we want to monitor a population of a particular species or different species in a particular community of a certain protected area ecosystem. So we can use drone and with integration of other technologies to monitor this population that we have. And I'm going to showcase us some of the examples of how we can use this utility function of drones and GPS and how we can mainstream them to biodiversity conservation. So the next thing is remote sensing, that is data acquisition and data processing and manipulation. With remote sensing technologies, as we all know, that it helps us to acquire Earth phenomena as a geospatial information. So we can have this information in form of our data in which we can use for any purposes that we want. And then, or we have techniques in which we can process this data and without even moving out from remote sensing aspect or using the remote sensing technology, we can give out this is what is happening. We can showcase this is what is happening in the ecosystem. This is what is happening in this particular, this is what is happening with this habitat component. Then GIS then now encompasses all these functionalities that we have been talking about. You can use it for data acquisition, you can use it for data processing and manipulation, and when you can use it for data management. I have said earlier on that you can use GIS to store data as a database. And then once we know about this function that we can use with our geospatial tools, whether we want to use it to acquire data, or we want to use it for processing, or we use it for to manipulate or do some analytics, or we want to use it for as a database management system. So these are some of the tools that we can use. There are numerous tools that we can use, in which some are free, while some require license. That means they are commercial based. So you have to pay a token or a particular amount for you to get access to it. So some of which are QGIS, and this one is a license-based GIS software, and it's very reliable and robust and have a wide community. What I mean by a wide community is that you can, if you have any issue, it's very easier for you to get solution for it, because when you're talking about any technological software or tools, the first thing you have to know is, does this software has a robust community in which if you have an issue, you're going to see they are going to provide solution for, not that they are going to provide that solution for you directly, but with their information over in all the net or internet, you can get your solution done and then you move on. So ArcGIS is a robust GIS tools, but it is a license-based, that is commercial-based tools. However, we have QGIS that is there for us, in which we can use. It's basically free, in which at times we need to be install some packages, whether you just connect to your internet and download your packages, different packages that you need to integrate. So you can integrate GBI, you can integrate remote sensing packages, you can all different packages for different analytics or different approaches that you want to use, just for you to just connect your internet connection and download the package. And some are free, some are already installed on it. But the next thing that we have is Saga. Saga GIS is doing the same functionality with GraphGIS, So it's for remote sensing analytics, or remote sensing, you can use it for remote sensing work. And then we have the Progress SQL. So this is a geospatial database tools that we can use as a GIS. So it's very robust in monitoring geospatial database. So you can use this tool. It's very robust and has a very range of community. And then you can move into web server or GeoServer. These tools are majorly for those that are into GIS developing. Those are in GIS programming. So this is that develop GIS application, mobile application or web application. So these tools, GeoServer, Map Server, so you can use it as a tool. All depends to develop different GIS-based application, whether mobile or web GIS application. And some of the tools that we can get acquainted with in acquiring our data. I said earlier on, one of the functionalities of remote sensing is for data acquisition and data processing and manipulation. So we need to know some tools that we can use to acquire this data. So one of the tools that we can use, we have some in which you are going to pay for it, which depends on the resolution. So there are data we have, because we have data of different resolution. We have those ones that are low, they have low resolution. We have some that are medium, and we have some that have high resolution. There are some platforms that we ask you to pay money, but for you to get a robust work, there are many other tools that in which you get a very good resolution of different data, and then you keep using it for different remote sensing analytics that you want to be engaged with. And then some of which some of us know about is using USGS, Earth Explorer, Glowfish to acquire data. And then the one that's developed by the Indians, ISRO, the Japan, that's the JAXA. And then one of the one that is I will also recommend for students to use because of its reliability and in which I've explored over time, in which you can just do most of your sensing analytics there, and then you can easily export it back to your GIS environment or GIS canvas. It's Google Earth Engine. So here you can do majorly all the UIS remote sensing utility function. You can use it for data acquisition. You can use it for data processing. You can use it for data manipulation. You can get Landsat data from there. You can get Moody's. You can get Sentinel data. You can get different data of different varieties of scenario, population, fire, land. If you want to do classification, maybe land and score, you have a lot of data to work with. And then the next thing that we need to get acquainted with is remote sensing data processing tools. So as I said earlier on, Google Earth Engine GG is very reliable. So you can, as you see, you can use it to acquire your data, and at the same time you can use it to process your data. And then when you process the data, you can use it to finalize your work from A to Z. For example, let's say you want to work on mapping, or you want to detect changes in a particular protected area ecosystem, or you want to perform a time series analysis, or you want to do land use land cover classification, or you want to implement your different algorithms, machine learning algorithm, you can do it on this platform. However, this platform is online. It's basically online, so it's just share tools that you can use online. But it involves using JavaScript and Python programming. So you need to get acquainted with this program language. This program language is not, you don't need to be like huge programmer before you use this tool. Just know the basic syntax, then you use them, you move on. And also, the other tools that you can use that they are not really like the Google Earth Engine is ILWIS, EDRAS. So they are very good for digital image analytics. For remote sensing tools, they are basically for remote sensing, and then you can explore them as you wish in order to implement it for different projects. You have ecology project that you have, or you want to mainstream into biodiversity conservation. And the drones and the GPS. So we have different drones and we have different GPS, but basically I just try to showcase to us like so that we get access to some of the drones that we have from the market. So we have the Mac, we have the Mavic, we have the DJI, we have the Mavic Enterprise, we have DJI Phantom 3, we have Phantom 4, we have Mavic 2, we have Mavic 2 Pro, we have Mavic Enterprise. So all this, they depend on their camera or basically the way they are being strong to fly in the air and some of the things like that, all the resolution they are going to give you. So these are the major difference in this. And you see, okay, Mavic, no, it's just something is changing. Maybe their camera or the way is being strong to capture data in the air and give you a very reliable resolution that you want to work with. And also we have different GPS, we have the Garmin, we have the Megaland, and every other GPS type you can work with how you get to use for your research work or project. Then the next thing that we move on is drone as geospatial utilities for we African conservation students. So what are the utilities that we can get from the drone? So one of the things we can get from drone is an orthophoto. An orthophoto is just an image you have when you fly your drone. Let's say you want to monitor a particular habitat component. You want, for example, you want to get where there is, maybe a particular threat into that particular area is that there is more people are getting into the protected areas in which they engage in deforestation activities. But we know that if you try to intervene, you will not get reliable resources to monitor these changes or this threat. So you can use drones to map it out, either to get video or an images that will give you the overview as if you are using a Google Earth or a Google map. If you want to transform it to a satellite view, so you are using a Google Earth, you are seeing in form of you are seeing a Google Earth images. But in these times, this is more reliable. It has high resolution. You are going to see the way you are going to see your object is going to be more real than the Google Earth that you are going to be using, and it's going to be in real time. So that's the difference. And also we can have the DSM. So DSM is the user surface model. There's a difference between DSM, DTM, and DEM. So DSM involves natural and artificial features in which you want to get your landscapes. Let's say you have a forest reserve as well. So it's going to give you the elevation, including the decline on the object on that particular landscape. I'm going to show you when we move on. And also we can use drones to get a vegetation indices. For example, with that scenario that I make earlier on, that in a protected area there's been a threat whereby there is tree fell, that is deforestation has been going on, but you are asked as a manager, or what you want to do for your own project is to know you want to estimate the area that's been deforested in that particular area. So when you use your drone, you get images, you map it together, you process it using different tools that you think you can use, which is such as WebODM or Pix4D or Agisoft. So you can get your analysis without moving out on the drone tools. You can get your vegetation indices and know where is that, in which area are being in which the deforestation is being severe and low and moderate or something like that. And also against a 3D view, because what we really get is 2D view, which orthophoto is a 2D, but however, you can also get a 3D view in which we have your in form of X, Y, Z. And also you can get your geotiff data in form of a remote sensing, in form of a raster data, which you can get it as a multiband and you can get it as a multiband. It depends on the camera that you mount on the drone. This is some of the scenario in which drones has been used and which I myself have been able to explore over the years. So you can use drone for species detection, counting, and measuring abundance. So with the use of drone cameras, mounted LiDARs, and sensor, you can use thermal cameras. Thermal cameras is now more reliable, and one that is now trending in this domain is using of LiDAR images and sensors. But LiDAR is now more trending. However, thermal images is also trending as well. So this gives enable researchers to monitor species and populations of different species in different ecosystems. For example, a koala is which is a native marsupial in Australia. So what I did, which I get a lot of images in which I integrate machine learning and I integrate a deep learning approach in which is an AI. So I integrate that is an artificial intelligence techniques. So what I do is that with the images that we get with the drone shot, I train the models, and so that it's going to detect when we are monitoring the species of the koala in the forest. So it's going to detect, okay, this is a koala is moving on because it's a native species to Australia, and so it requires a more conservative approach in that particular area. So, and basically is what I've been working on for my PhD program. So that's why I started a pre-exercise on it, and then this is one of the approaches that you can use drone for. And then you see here that it's able to detect, my model was able to detect 0.6% accurate, and then the other one, that is 60 to 80%, which is more reliable. However, it requires some improvement. And also, drones is being used in measuring abundance. You said I also mentioned earlier on that I'm involved in different international projects, and one of the projects I've been involved with the UNDP project is I've used it to delineate the abundance of a species. I'll be very confidential in mentioning the name of the species because it's a confidential project. That's why I'm just saying a particular species. So the species is very abundant in the state. So it's a disease that can cure diabetics. So what is native to this region? So what the question answer that they want to answer is what are the environmental parameters that makes this flower species to be growing well in this particular area? And the answer is, can it grow in another area so that it can expand the conservation priorities of this species? And this is one of the techniques you can use drone for. And also, as I said earlier on, when I'm using the vegetation indices that you can use this to detect habitat, you can use habitat systems and monitoring. Now, this is a typical example. So drones can be utilized in detecting changes within an ecological landscape. And then you see from this map, you see some areas are well green, while some are not green like that. And then that shows that this area does not have more vegetation, and then the other ones, the ones that are very green, they have more vegetation in there. So this one, when the administrative or the management authorities saw this, they will know, okay, this area needs more conservative approaches, or they need to replant or strategize on how to conserve the protected area or the landscape. And also you can use drone technologies for terrain mapping as well. So with the use of different tools, which is some are free and some are commercial, which is where for you to pay. However, with the multidisciplinary involvement of ecologists and other disciplines, so they will be able to develop a reliable tools for ecologists to use, which is free, and that one is RoboDM, and it's well reliable with what the commercial drone processing tools are done now as well, so which I personally is used as a student. So I use RoboDM a lot, and it's giving me a very reliable resource, and I'm very confident in the output I got from RoboDM. So PIS4D is commercial, Agisoft is commercial. However, they can give you a trial for like 2 to 3 projects or a particular days. After that, they ask you to pay. Whereas you can explore RoboDM, in which you use for the drone analytics and use for different terrain mapping, in which you get different terrain products. You can get the DSM, you can get E-shape, you can get aspect from it, in which you can integrate for your other modeling or for other analysis. And then another thing that we can use the drone for is, as I said, you can use for 3D, and this is a typical example of what you can have. Then we move on to the geospatial analytical concept of GIS and remote sensing for geospatial, and for the geospatial analytical concept of GIS and remote sensing for weak conservation students in Africa. And the first thing I'm going to mention here is these techniques I'm talking about. They are some of the tools or the fundamentals that you need to get yourself with. Because when you're learning GIS, majorly what you are going to be showcased is how to use the tools, how to use a particular tab, a menu. So, but for you to know how to integrate, how to use that particular tools, you need to know some concepts, some geospatial analytical concepts, in which you need to know, so that you on your own, or when you are involved with different projects, you will be able to use it as well. there's one for you to be able to, for you to know how to use the tools and for you to know how to use it technically. So here we are going to technicalities of using geospatial tools for conservation studies. So one of the tools we can use is mapping where things are. Well, you can use it to map out where you have occurrence. You can use it for getting occurrence data, either you use of GPS or drones, or you use different clouds, or you can also use global biodiversity information facilities, that is GBIF. But basically, you can, when you want to know where your species really are, based on different environmental conditions over time, there is changes. So you want to know where the species can survive. Basically, you might not, when you are learning how to use GIS, you might not be taught how you can do this. But you have to know these techniques. These techniques is how, one of the techniques you can use is, you must know how to thresholding techniques, because you have different information with your data. So there are where, for example, in your raster data, they are in form of gradients. Let's say, for example, NDVI. NDVI normally used to be in 0 to 1. At times, some convention put it as 10,000, and some convention put it as 100,000. But let's use the convention that says 0 to 1. So here you have 0 to 1. You want to know which areas they have lesser greenness in the particular protected area. That means in which the green is being reduced, you have less green. Maybe there is a particular, the way people are cutting the trees in that area is too much, in that particular forest reserve or protected area is too much. So we want to know where in that particular area have been affected. Or, for example, for fauna, you can know, okay, where can this species survive? Whether there is changes. Let's say there is fire outbreak in the area, there is wildfire in the particular protected areas. But with this fire, you want to know where can this species survive so that you can plan more. The conservation authorities can plan more for them. So GIS is one of the tools that you can use. And one basic thing you use is, you know how to threshold your data, how you can control the value to display, and then how you can work with your features and your categorical features, your category features that you have in that particular data. These are basic concepts that you need to know. And then with this map that we are seeing here, we see that the first one, which is the left side from my own side here, has gradients, more yellow, or more yellow like this, or orange. And the one at the other side is green. It's just green. So this one tells us where exactly we can find this species. And then it's sea turtle in West Africa. So this particular analytics modeling was done to address the issue of bycatch in West Africa. So here, the conservation authorities know that, okay, this area in West Africa is the real place where we can find sea turtle. This is where we need to emphasize more conservation effort on. And this is one of the techniques we can use. The next approaches or technical approaches we need to know as a conservation student in Africa is know how to map where we have the most and the least. And how can we do that? We can use like mapping quantity. So when you're working with your symbology, basically you might be doing symbology, you are displaying different type of maps with your symbology. So basically what you are doing at times is to know where you have the most and where you have the least. Because if you show your legend, you see where you have I, maybe you put them into different classes. So that's the technicality you are using. So the technicality is different from how you use the tool. So if you know the technicalities, it's very easier for you to implement it to solve different problems. So you can use this for mapping quantity, you can use to create transition within classes, and then you can also turn it to charts. I'm going to show that in the other slide. So you can also use it to work with charts, and you can use it for annotation. And then you see here, the fig that I used to demonstrate how you can do this. This is an assessment that was done in Nigeria, in the forest reserve in Nigeria. So where we are able to know the area in the forest reserve that have been affected by invasive species. You know, invasive species is one of the threats to biodiversity. So we are going to know where that are very low, moderate, and high, and they are very high. If we have more invasive species, so this will enhance the conservation authorities to know where they need to where they put more conservation effort. And the basic things that we use, the GIS approach, is mapping the most and when there is list. And then the other technicalities we need to know with our geospatial tools is finding what is nearby. You know, we do a lot of buffering. Buffer, maybe like 50 meter, 10 meter, 100 meter. Buffer is an approach that you can use. But technicality there is what you are doing is you are finding what is nearby. Let's say you have a tray, a nature tray in a protected areas. But within the tray, we want to determine, we want to know the ecological edge. That means to be, or we want to know which when you are going within your trail, what has been the impact of tourists or tourists that are coming into the parks? What have been their impact? You can do that with your buffer 10 meters from the range or 100 meter, 50 meters. You can know their impact for you to be able to tell them, okay, in this area, as I'm moving on, don't move near this area. So this is one of the techniques you can use. And one of the approaches you can use is clipping, buffering, different values and feature extraction. Select what is nearby by creating buffer. This is your buffer techniques or buffer approaches with GIS tools is that you are finding what is nearby. You are doing spatial analysis of what is nearby or what is within the extent of a particular region that you are focusing on. And also you can use it to quantify different quantities you can use quantify nearness to different quantity and classes as well. So you see that this is the quantity of what you have. So it's not that you are knowing that you have this, what you have in more abundance, or you are what is nearby. Maybe in a particular or there's a particular scenario. Let's say you have an ecology in a protected area. So you want to know how animals or the impact of this ecology to the survival of, let's say, baboons or monkey in that particular protected areas. You know, the baboon will come closer to those ecologies to gain to, you know, the visitors, they will have their influence, they will be dropping their food, their distance. So the baboons will be coming so closer to that particular region. So you can use these techniques to know to what extent is this particular activities have impact on baboon behavior. So this is one of the techniques you can use in with GIS tools. And also let's move on to another one. And I said the other one that I will show you when you can work with charts. And this is a very typical example. Here is a particular scenario in our forest reserve in Nigeria, in which it shows us what is happening during the forest reserve. Because majority forest reserve is for us to have abundant floral species. But over the time, this place is being threatened with different poaching activities that's been going on there. So apart from visualizing the areas, although we can see in this area that we have more areas that are more green and much that have little patches of yellow. But this is not enough for some authorities. They know, they will say, okay, it's not much. But when they see which chart, from January, this is how the activities is going on. From January to February to April, this is what is happening. They will say, wow, that means within this month, these people have impact, they have this impact, or they have much of threat in this particular protected areas. Okay, we need to take action. And this is one of this is an area in which you can use GIS tools as a student, maybe for your project or for any other purposes. And one of the techniques you can use is you compare features and their indices. You compare features and their indices from 2020 to 2021, from 2021 to 2022, we have different data for that, and then you compare the data. So this is a particular technique that you use to map changes. And also you can use time series analysis techniques, which I put it as creating time series map, or you can work on formatting changes in values. One of the techniques you have to know when you're dealing with raster data is you must know how to work with your values, because one of the techniques of digital image analytics is working with values. You have to be well acquainted with that, how you can work with your values, and also to get a chart, how you can work with chart. So these are the technicalities that are important when you want to map changes. Then the other thing that we can also use GIS or remote sensing for as a student is how to measure or weigh geographic distribution. In a but in this, for example, in Oyo National Park in Nigeria, the one here, the second one here, we have Betsy, we have like an opposite layer in which I overlay the protected area on it. So you can map, you can weigh the phenomena in which you have in your study area. And basically, if you want to, for example, you want to do something on suitability mapping. So basically what you do in GIS, using GIS or using ArcGIS or QGIS is you weigh different parameters, different raster information or different ecological parameters in which you weigh them. So the one that are mostly important is the one that you visualize and display when you now put them together and you engage yourself with some techniques for you to overlay and weigh the data, weigh them. Which one is more important than you visualize them out, and then you get your stability mapping. And then for you to do that, you see the other one, when I'm mapping the koala stability mapping, which I personally do with myself. I use machine learning algorithm for this particular work because I'm somehow fond of using programming with my GIS now. So I'm trying to move up using basically pure programming for my GIS work. And then because it's more robust and you get more reliable results with it. So here you can see that when we weigh different environmental parameters in Australia, we get different areas in which koala can be survived. And also if you just go to Google Map and you just search Australia, you see that all these areas, they are where you have like forests, you have green areas. And this is one of the techniques that I used to do the grand scrutiny of what my model does, and then it's giving a very robust result of up to 97% accuracy. So basically, the techniques there is that we just weigh the different environmental parameters. Those are important, and so because some might not be important and some are important, because we weigh it with species occurrence data. So then we extract the data. When we extract information with this occurrence data and the background data, so then we now try to try to weigh them using a machine learning algorithm. So then we get our result. And that's basically major techniques in working with suitability mapping, ecological niche modeling, or climate envelope model. So that's the technique that is there. So as I said, we quantified the weights of the values over the layers. We can use reduction, you reduce, aggregate techniques to observe distribution. And the last technique you can use is weighing the geographic parameters. You weigh the different parameters to this area to get your results. And the next one is analyzing spatial features or spatial patterns. So most people do engage themselves with land cover classification, use supervised approach or supervised approach. What you're basically doing is you're analyzing spatial patterns. So which the major techniques you can use is you can use a supervised approach or use unsupervised approach. And on over time, some people have been using spatial autocorrelation measurements for their spatial pattern analysis. And then basically what supervised approach means, you have a label. And the classification we are seeing here is a supervised approach. It's not an unsupervised or spatial autocorrelation approach. Because that's basically you need to know the first thing when you want to use GIS for classification of features or patterns. Here you need to label. You see the first one here. This one at the left side, it have blue color, and the next one green, and the next one like yellow color here. So here you have your label. The label is you create a particular target. Then with that information, we now do classification. And basically that's what the models does here using machine learning. I use machine learning for this particular activities. So basically the technique there is this particular features that is blue. The information is going to be extracted. The raster information there is going to be extracted because this is a city. It's different from where we have vegetation. So there's different information that is there. Then the algorithm, the machine learning algorithm now, when the model was trained, now enable us to get the same or similar area that have cities, or we have vegetation as well. So that's one of the approaches. And I try to move on to estimate the areas that we have more vegetation here, and then we have about 9 kilometers. In this particular, it's a small city, so that's where we have just 9 kilometers, and then where we have cities and we have bitops. Because nowadays, I will recommend that when you try to represent your map with, when you represent your outcome of your analytics with maps, try to give it a graphical representation as well. So it's make it more robust. It makes anybody that is not into GIS really understand what is going on. So wow, so this area, yes, we have a lot of ash color here. So the estimation of this particular landscape is 9 kilometers. Wow. So the person will understand better of what is seen with the map. So and the approach basically we can use is supervised classification approach, unsupervised classification approach, and then you can use spatial autocorrelation measurement. And however, this spatial autocorrelation measurement is not more robust, or however, it's not that recommended, but you can still use it. It depends on what you are using it for. And another thing is area measurements or line measurements. Basically, you might be doing it for fun when you are measuring your polygon, or you're measuring distance maybe a particular road or street or nature trail in the protected areas. But this is a very robust technique that you need to get acquainted with your geospatial technology or the skills that you have. You must know how to measure things in form of whether the areas or in form of lines or areas or perimeters, because majorly what the decision maker wants to know is which area, can you give us the estimation of the area that's impacted? Can you give us the estimation of the areas that we need to work on? So then all your research work, which you know you use your machine learning or you use your any models in GIS to know where we have, and we use forest change or dynamics in the forest component that you have in a particular ecosystem. So when you do your classification and you do your spatial analytics, so you can also tell them, you can also go on and tell us that, okay, this particular area in this year, for example, you're having on fire outbreak in a particular protected area for the last 5 years. So you can tell in 2017, this is the estimated area that's impacted 2018, 2019, 2020. So apart from just visualizing the map, so the real technique you can work with is using mapping area measurements. So in which here we have the total landscape of this area is 12 kilometers, and then the vegetation, the greenness of this area is just 9 kilometers. As I showed the area on here, we have 9 kilometers, and then we have not up to 1 kilometer, and the other one is just above a bit 2.1 kilometers, and that makes a little sense. That gives more information to the decision makers, and also these are additional paper, because the essence of doing research or working on a project is to make impact or to get a positive outcome. So after that, so I said that all these techniques or functionality that we're able to emphasize on, so there are some GIS techniques or GIS utilities. We might be thinking that they are basic things that, okay, vector, I'm working with raster, but they are very important, and they include the following: spatial data. So spatial, you have to understand this very well. There's something between vector and raster. So a rasterized information that have DN number. DN number means a digital number. In this pixel, when you're seeing raster, this pixel, they have different DN number, different digital number, in which, or pixel value. Some call it pixel value, while some call it digital number. So any features on Earth have different digital number or pixel value. So with this information, what the modeling that we are able to do, for example, here, so is this, we are working with different value. For example, in this koala, so rapidly mapping. So we are working with different values, different DN numbers. So this is what we weigh using our algorithm, or we try to use our model on to get this particular result. So you have to know what a raster is. It's not just a map. It's not just something that you are seeing. So it contains a particular information. And you can see from the terms, a vector, the position of the map feature are stored in coordinates X and Y. And then for the raster, as a grid-based format in which map features are shown as cells or pixels in grid matrix. So the information that you have here is not just no picture, but a particular information in which it can, if it's the vector, you have your coordinate, which is X, Y, Z. But if it is raster, you have what? You have your pixel value or digital number. So you have to know this when you're working with any sense in GIS or no sense. And basically is your points, your lines, and the polygons. You have to know, you have to get acquainted with how you georeference your data and then how you work with digitization. These techniques, they are very important. So when you are moving out on projects, for example, the drone mapping projects in which I involved with that international sponsored projects by UNDP, I'm going to tell you that when I want to validate my the map, the drone map, the area that was delineated as the areas where the species is more abundant. These tools this approach that you are seeing, georeferencing and digitization, I use these techniques, I use these tools with my GIS, using QGIS and Google Earth for me to get the desired outcome. For them to be satisfied, okay, this, okay, yes. I just show them to the project manager and this was accepted. Because I work on with these small tools, not that you're just georeferencing or digitized. So these tools, these techniques they are very robust. And although they might be simple or they might be sounds fundamental, but you need to get acquainted as a tools that you need to work on. However, Leon has showed us last course and then how you can go through the course and then you learn more from that course as well. So, and this is just the basic terms you can get, like the lines and direction of a road or rivers. So line can represent a road, river, street, like that. And your point can be a place or a particular building or a particular component. You can use this yet for the components. But when you are moving on the depending on the scale, because at times the way you use, I have to mention this, the way you use points and scale, it depends on what, and the points and polygon depends on the scale of your map. So when you're using a large scale, you know, is it designed for you to use a point or a polygon? If you're working with a small scale, are you going to use a point or a polygon? So when you are working with your mapping, so you need to know how you want to represent your geospatial information, either with point or polygon. Some people use some people make it like interwoven where they're supposed to use a polygon, they use points. When they're supposed to use a point, they use polygon. But all it depends on the scale of the map that you are producing or you are working on. And the next one is working with point when you are doing your buffer or clipping. As I said earlier on, when you're finding what is nearby, or you want to know what is nearby using buffering and clipping. And also, you need to know more how to query your spatial data. Because when you have features, any features that you have in GIS, they also have attributes. So these attributes, you have to get acquainted with how you can work with querying those attributes so that you get a reliable map. For example, I showed here the information you have here is not just a coordinate, it's attribute. So you need to get work done with this. You need to know that this. And then your database. You can build your database using your QGIS or ArcGIS. The shapefile, DBF, PLG, you are storing a database. You can map them, join them together, and you can modify them as well. And then working with raster data, you can project, you have to know when you are processing your data. These are the basic things you need to know. You need to know how to, when processing techniques is, you need to know how to reproject your data. Maybe we are working on the extent or the coordinate system or the scale. You have to get acquainted with these things when you are working with remote sensing data. And also maybe you want to do radiometric correction or atmospheric correction. We have a lot of cloud cover. So you need to know this when you are processing your remote sensing data, or you want to remove shadow, or you want to do something like image registration, or you want to do some spectral index calculation. For example, you calculate NDVI. And also, you want to get a robust result when you're working remote sensing. You need to know more how you use these techniques digital image analysis techniques, image enhancement. So the more the more your image, the more you can get a reliable resolution of your image, the more you get more accurate results from the raster data. So these are techniques you can use. You can enhance your data so that you have a very good you process your raster data very well. You can use these techniques. You can use contrast manipulation, you can use smoothing and edge extraction, and also I can go with image classification. And then the basic thing that's fundamental thing is map design and cartography techniques. So you must know how to produce a very fine, attractive, interpretive, a map that is well interpretive. So what techniques can use is how you work with symbology, how you query and work with features and attributes, and how you work with classes and group layers. So this is very important to utilities of GIS you can work with. Sorry. And other things you can also work with GIS is performing proximity analysis, tenant analysis, or suitability mapping. So at times I've shown how, for example, I've shown the suitability mapping analysis, tenant analysis, and the proximity. So there's no need to go back more on that. And then the real thing that we are here for, how can we mainstream these technologies into biodiversity conservation? So all those times, all those workflow that we have walked through is just the basic way we can mainstream geospatial technologies to biodiversity conservation. How? As I'm saying, so the major thing here is for us to know how we can use these technologies, how we can mainstream this technology that we have to biodiversity conservation. So majorly, we must be expecting a robust text or a robust information, but it's better to get a precise information that gets a lot of information. So this, I'm giving us a precise and concise information, which is very useful and which I've been, as a student as well, I've been able to use over the years. I think I've been working with GIS now is more than 5 years. Yes, even more than that, but let me just put 5 years because I started working with GIS when I was in secondary school. My experience in GIS started from my secondary school. But however, we are not into that. We want to know how we want to mainstream geospatial technologies. So basic thing is, number one thing is, you have to know the utilities of the geospatial tools that you need to know, that you want to implement into your project. Which utility function is being required, or you need, or you can afford, or you have the skills for your project work. And this is the major thing that you need to know, or that this is very important. It's not all tools that you need to know. If it's 1, 2, it's okay. If it is more specific to your own domain, it's all right. Then that's the first thing. But first, if you know, okay, this is the functionality of the tools that I'm using. Then that will enhance your creativity using to solve problems, to solve different conservation or ecological problems, because you know the functionality, you know how you can use it, you know the technicality with that tools. And what can enable you to do that is for you to know the utility function of that particular geospatial tools, which is very important. But after all, you know, okay, I need these functionalities, these tools to implement this action. So next is which software, which dependencies you need to know, or if you don't have the skills before, how can you know how to use these skills? And that's the next thing you need to move on. Then after that is for you to know the concepts and the utilities of that particular tools that you want to use to answer or to solve the problem, or to engage yourself with different projects or research works you want to do as a student, or maybe maybe after your school you get employed for a conservation program or something like that. And this is just the workflow, the basic or precise way you can mainstream geospatial technologies to biodiversity conservation. You need the utility or the function of that particular tools, then you need the software. Then if you have the software, how can you use the software, the tools, all those techniques, all those things that they have developed into that tools, how can you use it? And that's the next thing that you need to know. Then with this, you'll be able to use that tools, the special tools, to give answers, or to give solution-based approaches, or to provide problem-solving techniques to conservation or ecological problems or conservation issue that we have in your community or in Africa. Then I have these resources which I wish to share to everyone that is interested in remote sensing and GIS. However, I'm still going to do some updates to these resources. I hope to have more robust resources in which we can all explore to learn, because we are all here to learn. So we have this PowerPoint. If I hope it's going to be shared, and I hope it's going to be shared to everyone that attend this program, so that we can explore it and we can learn more or two things from it. Then the next thing is, when you know how to mainstream these geospatial technologies, then how can you really start implementing? Implementation is the best. If you know a particular skills, the next thing is, how can you implement it? How can you use your skills to solve real life problems? And that will not make you to, and what makes that skills to just be like that. Because you can have skills, if you are not using it, you just be using the value of that skills. Because maybe you have that a particular skills and not using it, so you might forget how to use the skills. But how you can get yourself with it, one, you can engage in volunteering with different organizations or different project work. Now, I'm about to do a project that I saw, maybe they want to say, okay, I'm currently working on this. I know that you can add value to that particular project. Contact that person. When you contact the person, showcase your value to them. What you can add, the value addition with your what you know. Tell them you want to volunteer. Start afresh to volunteer. When you volunteer, then you're going to get opportunities which can fetch you. Maybe what you want is anything that you want in terms of values. Let me put it that way. But at times you can start volunteering, which is free. You might do it for free at start, but at times it goes on. I'm very sure you're going to get more value attached to what you learn when you're volunteering. And that's one of the things that helped me over time. For me to go as a student and working from local projects, region, and to international extent. And also, however, I might be small, my background might not be what I'm doing in this sense. So my background might not what maybe the scale I am. That doesn't mean anything. It's what you know. People want to know, what do you know? How can you implement things for them? That's what they want to know. They don't need your background. Can you solve their problem? That's what they need, which what you have. And after that, when you move from volunteering, maybe in your own aspects, you love engaging in internship, you can do that. It will give you more experience. You are going to gain more experience when you gain in an internship. And also in your research or project work, try to implement these tools in your work. It's going to help you a lot. And then also try to involve in collaboration and partnership. It's very, very important. And also, maybe when the way you are learning, you need to support yourself as well. So as an African student, when you are learning a new skills, it takes your time and the likes like that. And also you may need some tools or some things in order to support yourself. So you can also get into a contract or a finance work, and then so that you'll be moving, you need to set a goal. For you to get there, you need some support or facilities or resources. I mean, you need tools or gadgets or money, and so that you get to where you are planning to, in order to use these tools for your project, for different conservation projects. Since you have interest in it, you can engage yourself in contract work or freelance work as well. I think with this, you'll be able to use your skills, and then your skills is not just going to be like that. You learn it and it's like that, but try to implement and practice. And then over time, you are going to become a professional one day as well, in which all of us, we are working towards as a student to become a professional. And I'm going to say with these little points I have with me, I will say thank you to everyone. Thank you for listening. Thank you for your time. And I'm going to say to everyone, let's keep learning. Thank you.
All right. Well, thank you, Akano. So we had some, well, first was just a statement. So are we correct that biodiversity encompasses even the lower level of organization? And this, of course, is the gene level, but we can also map these lower levels of organization. This would be things like insects or even lower than that, because we could technically, if I'm correct, map things within an insect's body as an example.
Akano, would you like to comment?
Can I get some form of chats? I can hear only very well from here. I don't know. The internet band or bandwidth is very low. Can I hear?
Akano, just tell me if I'm clear now.
Yes, I can hear you now.
Okay, so we just had more of a statement than a question, but it was asking about biodiversity encompassing even the lower levels of organization. And I have added on, would I be right or correct in saying that we are able to use our mapping abilities to be able to map things within a very small area, even if, for example, that was on an insect's body?
Yes, we can use it in a low scale. Let me put it as a low scale so that we can get it. We can use this. We can use all these techniques on a low scales, and even starting with a low scale is it's more proficient to start with something in form of low thing and then trying to increase it to extend it like that. So yes, it's something that is effective, and not only that it is possible. It is very, very effective and accurate in doing that. Yes.
Okay, fantastic. And then Samuel, we had a question. What is the distinction between biodiversity and wildlife? Which, of course, wildlife is a form of biodiversity. Biodiversity is every living organism. Wildlife is a term that we use to say biodiversity that we don't technically have control over, although you could argue that point that perhaps humans are controlling biodiversity at the moment. And then, Akano, we had a question from one of your students. Can we make use of all of the indices on a single GIS data?
Can we make all these indices on what?
Well, the question, can we make use of all of the indices on a single GIS data?
Yes, but yes, we can, but it depends on the data you are working with, because we need to work with the right data. That's the first thing. So we can use with one particular data in GIS, and then most of the time, you can, if you can explore Google Ads engine, you see different bands, single band data. For example, like forest cover height is one. Forest canopy cover is different from forest canopy height. And also tree cover at times, not just forest, vegetation cover. We are information, raster information that have vegetation cover is also different from the one that have forest canopy height or forest canopy cover. So this is a simple GIS data that we can work on. When you download the data, you can implement, you can use it for any analysis or any other thing you want to use it for. So you can, yes, it's things that you can work with. That means you're working with a single band raster data or a single informative, a particular one attribute. Your features have one attribute that you are working with, and that's just the basic, the fundamental things that you are dealing with. I think I'll be able to answer the question.
Okay, I think so. Are there any hands up? I have one more in the chat box. I don't see any hands up, and we are running out of time. So Sophia Hammed, or Hassan, sorry, one question or one statement rather for you. This is a whole encompassing GIS experience. My advice to you as a student, you said you are new to GIS, don't dive in, don't overwhelm yourself with materials. Sign on to our course, do the course slowly, listen to the guest speakers, and then you will start to have more of an understanding. If we were to just send you to your email hundreds of materials, you would not know where to begin and you would give up straight away. So there was one more it just disappeared. Maret, you just sent me a message. Somebody had their hand up, but it...
Moketsi Martin. I'm going to ask him to unmute.
Hello.
Hello.
Can you be able to hear me?
Yes, I can hear you.
Oh, okay. Thank you. Thanks for a very well presentation. Myself, I have a question. Basically, actually, I'm working on. I'm actually monitoring some plant species called Spirostychus africana. It is illegally harvested in my region. So recently, I was trying to map. I was trying to map the geographical locations of the species. But then I had problems because the species are in patches. So that's sparsely distributed in patches. So I wanted to actually determine the area which is covered by those Spirostychus africanas. So I wanted to, I actually had a lot of trouble trying to actually map because the patches where the Spirostychus africanas are appearing is very small. So I actually have the problem when it comes to, I was using QGIS to map the plant species. So I actually had the problem because I think the scaling was too small. To actually determine the area that was covered by each and every Spirostychus africana. So I was very interested to know if there is somehow it can be done so that you can actually discover area covered of the sparsely distributed vegetation. How are you able to create that? Thank you.
Yes, I get your question. So, are you done?
Yes, I'm done.
So one of the things that you can use, that I will recommend is if you can use in ArcGIS, as you said, you are using, so it's very robust and then I don't know if you know about modules. You know how to work your modules in ArcGIS. When you combine different frameworks together, different toolbox, you just use modules 1 and 2, you combine them together. This will help you to work to do a suitability mapping in ArcGIS. So if you can, there are many resources online. If you go on YouTube or Google, you see how to do suitability mapping. So it will give you the geographic extent or distribution of that species. Because but one, these are the conditions for you to get that resource, to get that output. You will need to, that's data that you have of the occurrence data of that particular species. Then you will need other environmental variables, such as the terrain products. You need to know the slope where that particular species is being found. You need to know some environmental parameters that enable that particular species to grow in that particular areas. You know, temperature is one factor. The precipitation is another factor. The slope of that area is another factor. And then you can also work with other data, other information that you have. But basically, just if you can make research on, you can also set some ecological parameters on your own that you see on the field for you to combine those information together as a raster. So with that, you'll be able to extract, you already have your occurrence data with you, where those species have been found. So with that, you will extract information which are raster-based information from there. Then you'll be able to predict other distribution, other areas that you can find those species as well. And it's a robust work. It will happen like magic when you use that particular techniques. You'll be very interested in what you will get. Because when you have that data and then you use different models with it, and I would suggest that you can work with machine learning algorithm. It's going to be robust and it will work like magic. As I'm saying, you see that it will give you results where you can find those species, the distribution of the species, although they are sparsely distributed, and that is well interesting. And then you are going to get the likely, not more than the likelihood factors or likelihood areas of where the species can survive, but mostly where the species are, you are going to get most of them. So instead of you doing a lot of works, maybe on the field, you are moving around to know where you can find it. With this model, you have your occurrence data you can get in a particular landscape that you are working with, your study area. You get where you can get the species, and then you can move on with that. And you can use this with QGIS. You can do with QGIS, and then just work on search on how to perform suitability mapping in QGIS, since we are using QGIS for it. But if you want to work, if you want to move out, you can do with QGIS. You can do with Google Earth, and you can use R. If you know how to do R, use R. You can use R or Python. So, but you can use with QGIS. Just find resources on how to perform suitability mapping in QGIS, so we get a robust mapping or distribution of that particular species. I hope you get.
Okay, thank you. Akano, I think what we will do, if it is all right, can we share your email address with Mukesi, if that's okay? Because
yes, you can share it. Yes, you can share it. But however, for anybody that mail me, maybe I'm busy that particular times, don't be disappointed. But I'm surely going to respond to your mail if you send mail to me. But at times it might be late, but it might not be late. So, but I'm going to respond to your mail.
Okay, yes, we definitely won't be connecting every student, but please do look up Akano perhaps on LinkedIn and you'll be able to connect. Johan?
Yeah, Ali, I would just like to ask Moketsi if it is possible for him to attend on Thursday, because that will be an ideal question for Jonathan to handle, where he will have the program open and he can demonstrate it, and that will be to huge benefit of all the other students that might also want to do similar exercises, because I think that is a fairly generic function that people in conservation would want to use to indicate the distribution of a species.
Yes, yes. So maybe you can also wait till Thursday so that you get more information on what you want to do, and also for others to gain as well. So I love that answer from Gina. Thank you for that answer.
No problem. Thanks, Akano.
Okay, so I think students, we're going to draw that to a close. I apologize, we have taken 2 hours of your time. All the other talks, we will be having them shorter. But thank you very much. The fact we still have 51 people here is pretty amazing. So thank you very much.